Everyone, welcome back to Manufacturing Hub on this beautiful Friday afternoon. Vlad and I are certainly excited to get into the industrial AI applications theme, but also to continue the conversation that I suppose, Vlad, you and I started last week and then also 6 weeks ago and then also a year ago, and has just kind of ever consumed more and more of our life, talking about artificial intelligence and especially what AI looks like on the industrial side. We do want to go thank MaintainX for sponsoring this theme. We've got Nick on the show next week to go talk about what MaintainX is doing on the industrial AI side, and super excited to have Nick back on. That is always a fun conversation. On our side, if you guys are new here, welcome. If you've been here before, welcome back. If you are new here, over the course of the next hour or so, we're going to have an awesome conversation on industrial AI applications with Konstantin. And we want you to come along for the ride, right? So if you guys have questions or comments for any of us, you want to talk about specific applications, you want to talk about value, you want to go talk about any of that, please feel free to go ahead and drop it in the chat. We will do our very best in order to go ahead and get through all of those questions and comments. If it's really technical or we run out of time, as we did last week, we had 60 or 80 or 100 comments last week, and we didn't get to all of them on the show. We will do our very best to go ahead and get to them after the conversation. So without further ado, everyone officially welcome to Manufacturing Hub. My name is Dave. This guy up here is Vlad, and Konstantin. We'd like to welcome you to the show. Thank you so much for being here.
Thank you. Thank you for having me.
Thank you so much for taking the time, Konstantin, especially after the Prove It presentation as well as the conversation. I think that you're one of the most topical people, I would say, in our industry to speak about AI. So very happy to have you here today. Before we dive into the actual conversation, though, could you give us a little bit of a background? How did you get started in manufacturing, industrial automation, and explain to us a little bit better how you got to where you are today?
Yes, sure. So I have worked in manufacturing for over 25 years now. My time goes back to starting out of college in Merck & Company, and I was exposed to the world of pharma business, and little naive me thought that all the other businesses are just like that, where you have experts for every type of problem, and then you just need to find the right people to talk to. But I've spent close to 10 years, just under 10 years in the pharmaceutical world. And then I joined forces with my brother, who started his own business. And we were helping the food and beverage manufacturers, and the help turned into building customized MES modules quickly. But at the beginning, we didn't even understand that that's what they were asking of us to do. So we kind of slowly evolved into that as we tried to ask more and more questions about what needed to be done. And the one beautiful thing that I'm very thankful for to Merck & Company was that they gave me the Six Sigma background. So the process first focus was there from the beginning when we started the business. And we were always looking at what is the current process, what is the problem that we need to solve, and then try to figure out on this journey from where the manufacturer is at right now to where they want to be, what are the gaps, how can we help? And if there are software solutions that can help, that's great. But sometimes we learned we can just provide insights to people right on the spot and tell them, why don't you do it this way? And then you don't need to install any software to solve some of these problems. And it's the fun aspect of this type of engagement where we just get to see a lot of end-to-end processes. And we've been in this business for over 15 years now with delivering custom MES solutions, and always looking at the process end to end. So production planning, batch control, spending time with the shop floor operators, figuring out what we can do to make their life easier. And we always love to, like, whenever we see a new manufacturing facility, we always love to do the tour and see how the shop floor operators work. how they look. Are they happy? Are they not happy? Sometimes that can tell you a lot, right? Uh, and from there, you get the sense of the environment, the culture, and you move forward to talking about what problems they may need help with.
Let me ask you a couple of questions. Right, first one, I guess, in order of the story. Right, the transition from pharma to food and bev. Why did you decide to go after that vertical specifically, as opposed to your experience in pharma?
Oh, this is actually one of the easiest one of the easiest questions, because I the last job, the last role that I had in the pharmaceutical world, I was a vendor manager, and I was in charge of helping out to make sense of the 6,000+ vendors space that Merck had. And I remember that when I helped manage the vendors, there were all these criteria that said that the large pharma company won't even do business with you if you're
Mm,
small, if you don't have a certain annual revenue. So basically, coming out of pharma and then going back to consult them at least right away was not even an option. With food and beverage, what really attracted me was that as soon as I started examining how they managed a lot of their processes, I saw paper and Excel everywhere. And for a process oriented mind, that's like a gift, because it's all low hanging fruit. You just go talk to the right people, and you already know how you can improve that process. So,
mhm.
having visited the food and beverage facilities, that seemed like a no brainer. But of course, there was the opportunity to do this. So, at the time that I made the transition, there was a connection between my older brother and somebody that he had worked with before that called for help. And so it just happened through knowing people that
Mhm.
we were able to help somebody in food and bev. And as soon as we saw that there was a lot of Excel, a lot of paper, and it was way behind in certain aspects than even the pharmaceutical world, it was great, because now you can go and help them improve those processes.
Let me ask you another follow up before I pass it over to Dave. I'm curious, you've mentioned the Lean Six Sigma background, and obviously, as you know, the continuous improvement initiatives are extremely valuable. However, as you've also mentioned, there's a lot of different directions, right? You can touch anything from an operator panel all the way to an MES or MOM based solution, and the entire umbrella is pretty vast. How do you maybe identify key opportunities in a broader sense for a specific customer? You mentioned a walkthrough, but is there maybe a way or a takeaway for a customer on how to assess and figure out what are the good opportunities to pursue?
Yes. So this is an interesting question, because we had this discussion about the target personas with the marketing team. And there are different target personas that we work with, but there is a common thread. So we like to talk to people who are not only focused on their day-to-day job, but who also spot problems in their day-to-day operations and are not afraid to talk about them. And then you try to think, okay, who are those people typically? So
Mm.
yes, I do get that from controls engineers and from the operators, but to be able to hear a holistic identification of a problem from them, you need to get into that conversation, and you don't normally get into that just out of the blue. So if you think a little more, who would be the people that can bring those problems? They're usually a little bit higher up the chain, and they're looking for ways to improve something in their operation. So these might be their production supervisors, Very often it is the plant manager, but even below the plant manager, you may have quality directors. You, in some cases, have even IT directors looking at things and saying, well, I've been tasked with improving this particular process. So usually it's the people that observe something and they see things that can be done better that surface these problems. And so we identify with those people from the plant manager down. In some cases, we've worked with C-level executives. And I can tell you that it's usually when the company is smaller that the C-suite people are in touch with everything that's going on in production at individual sites. When it's a bigger company, it's the plant manager. It might be VP of operations and then down from there, because what you want is you want the right balance between somebody who sees a problem at a high level, but at the same time to not lose touch with the people. So am I losing focus on the camera again? Let me just fix that.
A little bit.
So the people at the shop floor, or your production planners, or your quality control lab technicians, they always need to provide counterbalance to the story. So if somebody says we have a problem with OEE, or we have high rework, you always want to check, what do the people on the ground actually say? What is the true problem? And then when you put two of those together, that's when you find out, okay, really, here's what the opportunity is. And so that's what we go by. But in those groups of people, we always try to tell folks, hey, if you imagine you were the business owner of this entire manufacturing operations, what would you improve? What would you go after? And those that have the ideas are the people that we want to talk to.
Mm-hmm. Makes sense. Thank you.
I like that, Konstantin. I like the story. I especially liked your comment of, as the vendor manager, there were only 6,000, and I'm sure everyone towards the bottom 500 or so were fighting to go keep their spot, and the next 500 were fighting to go get those spots, having worked in regulated industries before. 6,000, in fact, seems like a large number. All right. I've certainly worked and gone down the path of the large company wants like 250 vendors, and everyone else has to go work under that. And so I'm also happy that I don't spend a lot of time working with organizations like that, because to your point, we are not nearly large enough to go have the X number of tens or hundreds of millions of dollars a year in order to be successful with that. So I really appreciate that, and I really appreciate the stories of kind of how you go look and solve these problems. One of the things that really resonated as we were setting up this conversation was some of the tools and some of the AI enablement that you guys on the Eukodyne side are working and building in order to help with that. So can you tell us a little bit more about some of these AI tools and applications and how you're using that to go through the discovery process?
Yes. So thank you for that. So a lot of people talk about using AI to deliver value to the end user, the manufacturer, by installing something in front of them, right? And there is a lot of disappointment, I want to say, because people think, at least in bigger companies, that they've installed Copilot, that's the AI, and whatever it can do, that's the extent of it. But people don't realize that AI can be the great enabler, even if people like us who are providing a service, who are consulting, are able to do something more extensively with deeper analysis and faster, and bring those results back to the end user. So the point about the discovery, we are basically now empowering ourselves to deliver more value to the end users. And the example we were talking about is when we're able to go into discovery meetings and take notes, but you know how you have options these days. The best option is always, I believe, to go in person and sit down with people if you can afford to go in person. And then the conversation flows more naturally. And of course, if you go prepared, you're going to ask certain questions and get the conversation to really deliver a lot of value. And what we've done is we've realized that we can't remember it all. We can't remember everything that every person said, every confirmation they made. So if you get the permission of your client to record the conversation for the purpose of having a transcript, then you can have that transcript validated. And this is where the beautiful part with AI comes in. So in one of our engagements, we made the recording. It was a highly sensitive discussion. So sensitive that when I started asking Gemini, what online service can I upload this to and know for sure that this information is not going to leak? And I asked about otter.ai, and it said, yeah, you must be careful because if you check, they're actually being sued for not complying with privacy. So at the end of the day, we use the on-prem AI box to run OpenAI's Whisper model on the audio file from a phone. And this is where the responsible use of AI comes in, right? So I get this long transcript and I have to name the speakers. Okay, you can go through it, name the speakers quickly. But then I thought, this is my reputation on the line. So at this point, I better make sure that every word that has been transcribed is actually accurately represented in this transcript. So then you put it on a split screen and you have the transcript, and then you play a little bit of the audio clip, you listen to it, you see that it got transcribed correctly. So we did that. But after this, after you have that very sensitive transcript, you can mask all the data in it, convert all the real names to fake names. And now when you stripped it of identifiable information, now you can load it into a smart model in the cloud and give it your pointers about how you want that data evaluated. So at the end of the day, you can produce a large detailed document with all the fact-finding information. And this, again, we did this over a course of maybe 2 days in iterative approach. So the first time you get it, you look at it, and then you need to criticize it and validate all the improvement ideas in it. And you ask AI to find you facts and quotes from the internet to support that. And this is where it becomes real tricky, because once it does this, it may hallucinate and give you some quotes that lead you to broken web pages. And so we actually looked at all of the validation information, and if it looked strange, it was thrown away, and only stuff that we looked at, we saw that, yes, this makes sense, that stayed. So you go through this iterative process. But guess what happens? At the end of maybe 2 days of preparation work, you're able to deliver a high quality document that lists every possible thing that is an improvement opportunity. It's validated. Oh, and the customer asked for return on investment information. So we made sure that for every opportunity, there is an ROI calculation. But we thought, you know, these days, anybody can provide you any kind of ROI calculation. So how do we make it useful? So there is a section at the end of the document that for every opportunity lists all the calculations, and all the customer needs to do is plug in their own assumption, and they will see how the numbers change. And so now that we just hand off for free to the end user as a gesture of goodwill, and they can see that the value that they're getting from engaging with us is tremendous. So the next step would be to say, okay, out of this long list, I'm getting the camera back in focus here. Out of this long list of opportunities, which ones do we want to focus on first? And I must say that overall, yes, it involves some daring desire to go and do something for free, go like above and beyond, but it allows us to get to the value much faster. This kind of deep analysis we weren't able to do just a year ago like this. So you're able to put a lot of value up front, and then the customer can look at it and choose, okay, do I go with these people because they did this for me and they might do this again, or do I go with someone else, but it looks like they understand what they're talking about and trying to assess my situation. So you do give something of value, of tremendous value, and then people may come back and do business with you. But it speeds everything up. So the time to value is tremendous when we, as technology partners, empower ourselves. And I must say, even for the manufacturer, the cost of all this goes down. Because if you think about how similar work would have been done a year ago, 2 years ago, because it would have taken us so much longer, it would have cost more. Now, we give you answers. You give us the problems, we'll give you the answers, and it's much faster.
Absolutely. Let me jump in. I want to ask a couple of questions, I guess on two sides of this, Konstantin. And I think that most people understand the value and the need for security of all sorts of data. And so I think that makes sense. You talked about this box. You talked about being able to run, I think you said the OpenAI Whisper module on-prem. I guess take us down the technology path, right? So we understand the problem. Tell us about this box. Tell us about what models they are, how they're running, why you're using it. Take us through the technical side, please.
On the technology stack, this is the beautiful part. So you can go out today to Dell's website, or to NVIDIA's website, or to Lenovo or HP, and buy this box that is under $5,000. You'll see some variation in prices depending on when you look on Dell. It's called Dell Pro Max GB10. It uses NVIDIA Spark architecture. The reason why I prefer not to buy the NVIDIA box directly is because of the physical design. Dell made it more open to the airflow. So the thermal issues that people complained about with NVIDIA's design that maybe is more cool looking, but the air circulation is poorer. So Dell solved that. Dell also provides a higher power rated power adapter for it. So under $5,000, you get this Dell Pro Max GB10. It's a Linux server. So I know NVIDIA tried to position these as consumer products. They're really not. They're somewhere in between a consumer product and a server. It's basically a Linux server with a customized version of Linux that is NVIDIA's custom version. So they are preloaded with their drivers. And once you buy it, there's nothing on it. And so what we do is we then look, okay, what does NVIDIA recommend we do? NVIDIA nicely pre-packages these different configuration options that you can install in it. And they're nice if you're doing something as a hobby. As soon as you start using their pre-packaged material for work, you're on the hook for NVIDIA Enterprise AI license. And that license costs as much as the box itself per year, but they don't sell it on an annual basis. They sell it in chunks. So you're right away looking at another $20,000 bill, and you don't even know whether you're going to end up using this in the long term or not. So what we do is we stay with the open source models, open source software stack, and we tested some of the open source NVIDIA models versus OpenAI. And to be more specific, we try to balance performance and the smarts of the model. So what we found was a GPT OSS 20B model from OpenAI gave us a good mix of speed with which it generates the tokens and the ability to solve the problems. Now, I've had this conversation with somebody yesterday where people made an argument that, well, if you use frontier models, they always deliver the best results. Yes, but you have to ask the question, what problem are you trying to solve? So you don't want to just pay a lot for this frontier model just because. If you ask in manufacturing, what do most of the use cases look like? From my experience, it's more about finding a needle in the haystack than anything else. And so I can translate what that means for different use cases. So if you're talking about looking at sensor data coming from the unified namespace, you will have a lot of sensors with cryptically named MQTT topics, and then you have to map that to a data dictionary somewhere. Some historians now provide that built in. In some other cases, you have to maintain that knowledge somewhere else. But then what happens is after you map it all out, you are probably looking for that little bit of information. Maybe what's the temperature value of that temperature sensor on production line 1, 2, 3, right? So for large language model perspective, it just needs to go through that chunk of text and find the right information for you. So finding a needle in the haystack is the most common problem you solve. There are more. So in Prove It 2026, we were talking about how many people use knowledge graphs. Knowledge graphs are good for this specific problem. But then if I want to ask a question from my chatbot about a general observation in the unified namespace and say, has any of the available temperature sensors in my enterprise exceeded the value of 85 degrees today? Now you're not talking about one specific one. So there's a different pipeline to address that, where you're not going to the knowledge graph, but you're taking all the data from the sensors, you're putting it into a vector database, and the vector database seems to be doing a better job of all this. But where the beauty of this, like coming back to on-prem box, the beauty of this comes in is that on such a box, you can run multiple Docker containers that are all co-located. So if your performance in general is good enough, and that box has 128 gigabytes of shared RAM, VRAM, and RAM for the CPU, so it's pretty sizable to load decent models all at once, then because if they're all co-located, the performance is great. So you're able to immediately create a vector out of whatever the user just asked and compare it in different ways and decide on the fly, yeah, based on what they just asked, I can pick this pipeline and go to that pipeline and produce the answer. And this all looks transparent to the user. So it's not only that you save on the tokens, because all you're paying for once you have the box is just electricity, but you're also able to have all these different capabilities co-located together. So you're not experiencing the latency going between them. There are no hops. A year ago, when we went to Prove It, we used Pinecone vector database, and Pinecone is in the cloud. So anytime you ask it something, there is that added latency. Here, when you do it on the box, there is no problem. It's quick. So I wanted to say to people, go out, don't be afraid to spend a little bit of money to buy a box like this. We also did a workshop, and we have a repo in GitHub that's available to anybody, showing how to get started with something like this. Even if you want to use NA10, for example, we created a custom setup and made it available to everybody for free, where it's not just the typical LLM that's sitting on this box, but we built in a RAG pipeline. So if you want to preload some documents, and then you go to your NA10 and ask questions and do whatever you want with your process workflows, whenever you ask anything from the large language model, it automatically goes through the RAG pipeline. So you don't even have to build anything for it. So if you have documents preloaded, sure, it answers questions as if it always knew about this stuff. And anybody can do it these days. So your expense is whatever that box costs. When they're on sale, they might be closer to 4,000. When there's no sale, they're closer to 5,000. But I think it's an exciting time we live in terms of being able to play with these things.
Let me ask you a follow-up. I thought Dave
Yeah.
had maybe two questions, but let me jump in for a moment.
Sure.
So I'm curious, like going back to that example of generating, a customer report at the end of that
Yes.
conversation. For me, at least, I found that the value in LLMs is being very reiterative, right? Like giving them more and more information as it is, let's say, like not
Yes.
available on some of the first prompts. So I'm curious, like as you're engaging in these conversations, how has the workflow of your questioning changed? Have you seen maybe
Yes.
reasons to re-engage with the customer? Like, hey, I need some more clarifications to make sure this works. Like, how does that workflow maybe work for you?
Yes. It changed in two ways. And what you just said absolutely happened. So there was another example where we were asked to shadow the loading operator at a facility and basically come up with the improvement recommendations. And we're still working on those recommendations, by the way, because that is what I love about this. It turned out to be a hard problem to solve, because manufacturers not only give you an imperfect process, but they also give you the constraints and say, yes, give me something better, but it better not violate this, and that. And that's where it becomes more challenging. But to answer your question, so here's an example. I'm looking at the notes that were recorded over the course of 6 hours of shadowing the operator. And that contains text notes in the notepad that has some video clips of somebody saying something. So we start to put together a process flowchart. And by the way, we are building a tool to do this with AI. And this was an eye-opening revelation that AI fails right away in two instances. First, it tries to get everything correct on the first attempt without assuming that iterations need to come. And second, the people that you shadow frequently provide inaccurate or just plain wrong information. And so what happened was we were reviewing the process steps as we were trying to map it out, and something just didn't make sense. And we were building the tool to analyze this at the same time and doing it manually. And we realized, oh, okay, so as a person, I actually know, because in my head, there is context of that manufacturing facility. There is that institutional knowledge that's actually very valuable. And I know that A is not equal to B. I'm looking at the data I got, and something makes no sense. So I pick up the phone, I call somebody, and I say, listen, that doesn't smell right in what's in my notes. And the person says, oh yeah, of course, it's actually not that way, it's this way. And it just changed 180 degrees. And so as we were going through the mapping, it turned out we had to go back and make the call about 7 times. And once the corrections were made, then we took the understanding of everything and went back to that same operator that we shadowed and went through each individual step. And what turned out to be the final version of the truth was that while everybody thought that there was one process and it was complicated, but they didn't think it had 50 steps in it, we ended up having 7 variations of this process. And that required those iterations. So to answer your questions, as you compare what AI does, it tries to jump into conclusions based on imperfect data. And a person with institutional knowledge may know better and say, no, this doesn't line up with how these guys operate. And AI doesn't have that context. So, of course, an experienced technology partner who knows the organization for years has that in their brain to be able to validate it. So that's what one of the risks is when you just dive in with AI and start analyzing. You analyze everything at face value. But those guys gave you something wrong, and that's it. There is another part to it where when you observe somebody, when you shadow them, it might be information coming from multiple instances of the same process run in parallel. So what I'm talking about is if they have multiple loading areas in the loading bay, and they're loading one truck over here, they're loading another truck over here, you overhear the conversation of the same person that's handling all this. You might think that those data points you just got, they pertain to the same process. They are not the same process. Some of it is for this truck, some of it is for that truck. And when you just look at the notes, you can't tell easily until you remember visually how they operate. And then you go back to them to validate. And of course they say, yes, that was for another truck. So that kind of stuff, you can't naturally trust AI with, because it will try to give you an exhaustive answer on the first attempt, assuming that all the data that you gave it is correct. But you don't know that. The data came from somebody else. So there is that. But the second part, and I'm sorry for a long response to this, it just gets me very excited. We just started working on something new, and for the last week or so, we've been hammering away at this, where you can now teach your agents. So you don't program the agents, but you can teach the agents, and you can have two parts to your technology stack. One that is fixed, where you are putting all the rules of how we're going to learn what we're going to teach you about, right? And the other part is variable. And so the agents are able to change literally the code that they run to do the work for you. So there is a fixed part and there's a variable part. And I tell them that I will be providing feedback. You better record all the feedback I give you and all the changes you made, and we're going to improve the outcome of this. And so after going through 7 to 8 iterations, now we have a system that goes and looks at other systems' source code that we built, and it traces all the relationships, and it provides this knowledge base of how everything works, where the risks are, where the opportunities are. And it's amazing. It's the stuff that, if you ask software developers to document your system and document it well, how long is it going to take to do that? Probably they're going to get tired with that assignment before they finish it, right? But with AI, it doesn't get tired, but you need to teach it how to do this right, what not to say because it's useless, and what is of value. And we found that instead of programming all that, and every time that that you find something is not right, it's actually easier to teach it. And that's one of the ways in which we changed how we respond to things that we're finding, because now with the self-taught system that's doing it, again, we're able to deliver tremendous value in several days. So think about speed to value. That's where we transfer it back to the manufacturer to say, okay, because we have this capability, now you have the capability to ask us for something this week and get it shipped next week to you. So that's the beauty of it.
Let me ask you maybe a really quick, very brief follow-up before I pass it to Dave on a more practical side, right? So it sounds like you've experimented with a lot of different models and have benchmarked different solutions. What's your current preferred stack? I'm hoping, or I guess I'm assuming that you're using a lot of Claude Code, but could you maybe expand a little bit on the skills, MCPs? What are your thoughts there?
Yes, so it's Claude Code. We actually have everybody on our team, all the developers and non-developers, use AI coding assistants. And the beauty of this is you don't need to be doing coding necessarily to be using these tools successfully. So a great example is you can use Claude Code for server management. So I'm sorry to say, for those companies that provide server management tools, you have a tough competition, because when you have a small company, you are able to install Claude Code on every server. And you just tell Claude what you need done with the configuration of that server. And then maybe you're going to give it a few more inputs, but very quickly it's done. If it can be configured through command line interface, it's done. So that's why I now go with Linux and Claude Code. And you just have to be mindful of what hardware specs you want. So we use Vultr a lot for the private cloud. And it's a mix in the stack of things that we do on-prem versus everything else that we do in the cloud. And all the developers, they work with developer boxes now. So we're no longer relying, although I have a powerful laptop, we're not relying on coding on the laptop anymore, because it's much easier to configure the development environment on a server and give each of your developers their own dedicated server. And so they log into that session and they continue where they left off before they stopped for the day or whatever happened. Maybe they went on break. So Claude Code is used different databases. So we have SQL Server, we have Postgres, we have ClickHouse. And again, going back with the stack, it all depends on the type of problem that you're trying to solve, because the end user might dictate some of this technology. So we have the client that says everything has to be in Azure. They trust Microsoft, so then you go and you work with what you've got in Azure, right? But then if I need to bring in something like this box that we're talking about that has custom NVIDIA Linux installation, I then have to make an agreement with their IT that they're going to support it and that it goes on the isolated subnet, things like that. But I wanted to say that besides Claude Code, we use different providers because we wanted to always experiment and see where some of these tools are better than others. So we managed to modify Claude Code to use the Chinese Quen model. And we always check how far behind is Quen. Why? Because if you need a lot of compute, you just go to Open Router and you say, okay, here's Open Router, here's Quen, connected back to Claude. And now it may cost me less if I'm on this API plan, So we're constantly looking at that. We have people using Cursor. Mm-hmm. I'm not personally using it. I've used it a little bit and I stopped. And the reason why is because a lot of code, I would use the AND tool. So in my case, I use Visual Studio anyway to validate that the project works. So I don't need to see it in Cursor and then see it somewhere else. It all depends on the technology. So if your technology is a little bit older and we have a mix, then you still need whatever the IDE is to test it. And then you just use Claude in between, and you don't need multiple IDEs. So I don't need Cursor in the middle. And I didn't like in Cursor the fact that they're changing the configurations and shipping new features all the time. At some point, I come from a development background and I'm a patient person with the technology changes, but at some point, too many updates, too many new versions all the time, it's disruptive, right? Mm-hmm. So when Claude updates itself, I'm fine with that because it's still a command line interface. Nothing changes in terms of how I interact with it. So I love it. And then again, it all depends on your practice of how you validate the work. So we're still doing our testing ourselves. Of course, if there are unit tests that Claude can run, great, let's run them and see what happens. But at the end of the day, we're clicking through everything and checking that visually the product delivers. And then you can use another AI model like Gemini to review the code and critique it. And so in some cases, it's the combination of the two. So when we were solving this problem with coding the GPU MQTT broker, which we presented at Prove It 2026, we tried something that we never tried before. It was going into NVIDIA's version of the C++ compiler and writing code that is good for that. And then you ask yourself a question. If my ultimate goal is to get as great performance as possible, but I don't know what the ceiling is, how far do you go, right? So you're sitting there with Claude, you're iterating, and you're saying, yeah, okay, now our broker can process this many messages per second. And we're trying to shift all the processing logic from the CPU to the GPU. But you don't know where the ceiling is. So you're spending time, and sometimes you take a step forward, you take a step back. But what becomes really interesting is you can take, when you see that Claude is kind of getting lost and it's trying to do something, but it's not making progress, you then take what it does, you give it to Gemini Pro, and you ask Gemini to provide critique for what Claude is doing. And then you take that critique, you give it back to Claude, and now Claude can move forward. So I found that
really,
when they work together, it helps get through the bottlenecks. It helps to get the perspective of another bot that thinks just a little bit differently. Yeah, but then at the end, you still don't know, where do I stop with this, right? And we decided, kind of similar to how you stop with training AI vision models, you always watch that curve, right? And if it's flattening out and you're not getting any more incremental benefit, you say, okay, probably this is the time to stop. So with Claude, it was, how much benefit do I get versus how long do I have to wait? So when it tries to give you C++ code meaningfully, that actually works and creates incremental benefit, we got to the point where you have to now wait 30 to 45 minutes for each request to complete. So Claude just goes on and tries to move something else from CPU to GPU to give you that performance boost. And now you're waiting 45 minutes, and it comes back and it says, I think we've reached the point of diminishing return. So that's when you know you need to stop.
I appreciate that. So I've got a couple more questions about this hardware. We were going to go all the way to the other side with a community question about super small hardware. But first, we've got some people to thank on the MaintainX side for sponsoring this theme.
Here's the painful truth. Your technicians are spending 40% of their time looking for answers, answering radio calls, and not focusing on what really matters, fixing assets. That's why we built MaintainX. Now your technicians can leverage AI to get the answers that they need instantly, focusing on what really matters, getting the asset back online. Check out MaintainX.
Awesome. Again, thank you to MaintainX for sponsoring this theme. Super excited to have Nick on next week to talk about what MaintainX is doing, what MaintainX is doing on the AI side. Having said that, Remus brought in one of Vlad's most favorite shows, Silicon Valley, to go ask about black boxes. And we're not going to go any deeper into that comment because that may violate our current terms of service. Having said that, Konstantin, talking about the hardware, I guess in short, you have the Dell boxes. We've talked about the NVIDIA GPUs. What is the kind of short decision process of boxes and servers on-prem versus cloud solutions versus other things? If I am an end user, or if someone here is listening and they're asking the question, why would I go spend $5,000 on a box and get everything set up to go use as a server or server-esque versus going and using these cloud services? On your side, kind of what does that decision tree look like?
Okay, thank you. That's a great question. So with the last example that I gave, where we're making the agents learn, we're burning hundreds of millions of tokens per day. So think about the entire Claude Max subscription cost in one day, gone. So that creates a very powerful incentive to find a way to do this on premises where you're only paying for the electricity, right? But that's one of the use cases where you're trying to drive the bleeding edge innovation to say, hey, we want our systems to learn. If you're not doing that, there's another simple set of questions to ask. So in our case, when you go to the manufacturer, they're usually after something simpler. And the question is, where is it? So I'll give you an example. If we're talking to the shop floor operators and we're saying, hey, maybe we can provide this chatbot right where they do their work to help them answer questions about what they're working on right now. And this technology should observe everything they're doing, know the production recipe, and then if they have a shift changeover, it should be able to say to the next person, hey, the previous operator made it through 2 or 3 steps out of the 5-step sequence. You need to continue with the next one. So things like this, if it's on the shop floor, you'll frequently run into a situation where the IT or the organization as a whole will not let you connect whatever is right there to the cloud for security reasons. So, or if it's sensitive data, like I'm looking at the bill of materials all the time, they might say, oh, no, like other things, okay, but this is not going into the cloud. So a lot of it may be driven by the manufacturer themselves, and they would say, no, for whatever this data is, that's not going anywhere. So that would be the obvious decision factor. If it's not going anywhere into the cloud, okay, can I do it here? But if I'm doing it for myself and I have options what to choose, it's the math of tokens. What can I do with these on-prem boxes that would create tremendous value for me, that would not give me an incremental monthly cost? That is really serious. So just think about it. If everything that you ever coded, everything that you ever developed in your life, if you had access to that source code right now, and you could get very, very high quality review of that with insights that you can then draw on and make conclusions and generate ideas from for your future projects. Wouldn't that be nice to have? So if you are thinking, okay, how do I even do that? That's where the iterative approach comes in. It normally doesn't happen on the first pass. Well, if I have on-prem boxes to do this, then all I'm paying for is electricity. And it does take a lot of passes, a lot of tokens to trace every possible relationship that LLM lays its eyes on, and then come back and say, oh yeah, by the way, you're using this call here, it calls that thing over there, and that's inefficient. You know, so things like this, they're amazing. And yes, for any kind of insights where I'm able to offload iterative work, I would definitely offload it to on-prem boxes. But that's me, a person that has a choice. If the manufacturer just mandates that certain areas are closed off because maybe they have old PLCs, old SCADA systems, and they're not as hardened in terms of network security. So then they close the outer shell around it and nothing can go in or go out. That's where you bring that kind of hardware. And these days, the cost has gone down. So now the on-prem world is catching up quickly, where you would say, hey, for some of these use cases, you do not need the smartest model. You just need what works.
Okay. I appreciate that. I like that. I feel like we could have 5 more hours of conversations only on that topic, but I want to move us to a comment or a series of comments from Edison, who is hopefully still in the chat. As a point of reference, Edison is in Brazil, which may or may not be valuable to this point of reference. But he's saying that today there's a movement around model craft, which is the creation of highly compact language models that can run in artifacts as small as 16 megabytes. The approach opens opportunities not for only Industry 4.0, but also embedding intelligent agents in popular low-cost vehicles in Brazil, again. With smaller models, it becomes possible to bring advanced AI capabilities to low-powered devices with limited connectivity. And this I feel like is almost specifically for Vlad comment, but he's saying, considering that we face very high cost for dedicated hardware here, they often resort to purchasing like refurbished Xenon processors and GPUs from China. From a cost benefit perspective, it's become a friendly debated practice, especially as they look for new ways to bring technologies to industries and vehicles that have become outdated. Vlad, I feel like this would be a good time for you now to pick up your recently unwrapped hardware that you were unwrapping on the front end, and show everyone that you and Edison are competing for the exact same computers and hardware. But I guess, Konstantin, on your side, is that something that you have seen? It's almost the flip side of the conversation of the largest models and all of the tokens of getting as small as possible. Is that an area that you have looked at, that you have considered? Do you have thoughts on that topic?
Yes. So before Vlad pulls out the boxes that he had, I would make the point again, it all depends on the problem you're trying to solve for the manufacturer. Mm-hmm. So if the problem, like the art here is to find the lowest common denominator, you need just enough capability to solve the problem, because that makes it efficient. So if you can solve it with a tiny model, that's great. The models that we load into these under $5,000 boxes, we have 128 gigabytes to play with. But what I noticed, as somebody asked me this question, they said, how do I do something similar, but still in the cloud, just for testing purposes? And there are these websites, there's vast.ai and there's RunPod that allow you on-demand GPU access. And I noticed through there that there was some of these cards that go back to Edson's comment. Some of these cards that look really strange. So it would say NVIDIA RTX 4090, but the amount of VRAM would be 48 gigs. And I know that that card never came with 48 gigs. So I started searching it, and I found out that there's now a whole industry in China where they take these older cards and they put more memory on them. And so you can actually go to eBay and order one of those cards, and it would be a 4090 with 48 gigs. It never came with 48 gigs before. And so then it's a trade-off of what price, what kind of deal you get, you know. But I would say in those cases, like what Edson pointed out, this is definitely also a possibility, because now there is this new industry born out of nowhere where some clever engineers figured out that you can solder on memory chips. Yeah, NVIDIA is not giving you any guarantees, but NVIDIA also doesn't care if you buy 4090s in 2026 anymore either. So there is definitely an opportunity there for the markets where hardware may not be as accessible. You just need to find the parameters that are sufficient to solve the particular problem you're trying to solve.
I've seen the videos of modified GPUs for that specific purpose. It's going to be really interesting, I think, in the next couple of years, as that's becoming the bottleneck as opposed to software. There's a question from Remus that I want to bring up, which relates to your earlier comment about provisioning servers. And so he's asking, and I guess maybe the broader question is, how much better is it to manage via Claude as opposed to specialized tools, right? So he's talking about AWS, Pulumi.
Oh, this is very easy. This is very easy. So, by the way, for people, just understand this. When we do this for ourselves, it assumes that the server that you're managing has access to the internet. So in some cases with the manufacturers, if it's a server that runs at the manufacturing plant, usually it will not have access to the internet. But if the access is allowed, this is very easy to answer, because when you put Claude on there, you don't have to learn. So the learning curve of going through the specialized tool, knowing where to click to get the results that you want, you don't have to do any of this. You just have to say what you want to achieve. And you obviously control whether you give it permissions to make changes right away or however you want to do it. But the beauty is that the learning curve is zero. All you have to do is type what you want. Now, of course, I'm making an assumption here that the person that is typing the request is not a complete newbie, right? So I have many, many years of software architecting, software development experience, but I may not be an expert in configuring Linux servers or an expert in configuring anything through the Azure CLI, you know, because in Azure, it's a known pain to get everything working. So this is where you can connect the tool like Claude and say, this is the result I'm looking for. And then it does something. And then you test it and you see, does it do what you want it to do or not? So you're not spending time on learning anybody else's interfaces. So that's the beauty of this. It's like zero interface learning curve.
I wouldn't tell Remus that AWS CLI is a pain because he used to work there, but I've heard similar comments to what you're saying. I think in the hands of experienced engineers, whether that's on the software side or on the DevOps side in this instance, then it is a productivity booster at the very least, right? If they know what they're doing and they know what they're prompting for, then it definitely saves time. I've personally not experimented with server deployments, but I can only imagine it makes it very interesting and something I definitely need to look into. There's a question from Zach I do also want to bring up, and I know that we're going on slight tangents. There are a few questions that we do have in our list that I also want to bring up. So let's get Zach questions in before I ask you a question from our list. So he's saying, awesome discussion, but it's not just about inference cost. It's more about price versus performance. I don't care if something costs me half as much if it takes me 4 times the attempts to get it right. Even when the fine tuning a open model, the model will still lag behind frontier models on general tasking such as tool orchestration, etc. Any thoughts and or comments for Zach on that front, Konstantin?
Yeah, absolutely, and I agree with Zach. The question here again goes back to what problem are we trying to solve? So what I'm seeing is that a lot of times people try to purchase capacity, purchase compute, without knowing what they're gonna use it for. And that's really the best. Like if I had to give advice on this, first focus on the problems, like sit down with a pen and paper and try to write down what are you going to be trying to solve. And I totally agree with Zach, because depending on what I am trying to solve, I would use one or the other, right? Where I advocate on-prem AI is for those tasks for me, where it's the token math, where I can get more value this way. But for the manufacturer, it's where they have the restrictive environment where they're not allowing access to the cloud. That may be something. So I was talking to a person that we may know together that tries to put chat into the PLC the other day. And the conversation was exactly about this, that at least all the customers that I know, if you're talking about PLCs, you are definitely not getting internet access anywhere near them. So he said that there are some that allow it. I haven't seen them in my experience. So then the question is, okay, if you want something right there on the edge next to the PLC and you have no internet access, how are you going to do this? And that's where the on-prem AI may be more suitable. But yeah, I go back to everything depends on the type of problem you're trying to solve. And so that's the answer there.
Yeah, and to your point, and I guess to reiterate and correct me if I'm wrong, the first use case that you've described, you basically used the on-prem box for transcription, but also to remove the identifier to then take that information and load it into a cloud-based model, right? So there was a specific use case for which that maybe like lower tier LLM is more than suitable for, but then you can use that data once it is stripped down of identifiable
Yeah, so
information.
it always becomes a combination of the two, right? So
Yes.
you use the best technology for the particular problem you're solving. Absolutely.
Right. Let me follow up, I guess, with a slightly different question from our list. I know that we're already over time, but last question on my side, at least. So,
I'm good, by the way. So
okay,
go ahead.
perfect. So, a lot of the conversations, and I know that we've talked about a use case where it's not about the plant floor data per se, but a lot of manufacturers are at least on the trend in my conversations where they're trying to extract as much data as possible
Mhm.
into historians, databases, but it is in relation to their sensors, their basically like their field devices, and are then hoping, or I guess are seeing the value in the future to try and query a lot of the data with LLMs. I'm assuming, and you had that presentation at Prove It 2026, you have done quite a bit of testing. So I'm curious, maybe like your thoughts, but also maybe some guardrails when it comes to just thinking, as long as we have a massive database, we can just put all of that and get a lot of ROI.
Yeah, this is a little bit of a loaded question, but yes.
Yes.
So where do I begin, right? When we did the testing with the Prove It 2026, one of the use cases there, it was about isolating noise from the signal. And we specifically picked a very, very difficult use case where adverse conditions. So when we spoke about cavitation in the pipes, where the high-speed filling of the bottles with carbonated soft drinks happens, the possibility of adverse conditions forming in manufacturing is so high. It's like you can get the adverse condition in milliseconds. And so for that use case, you need to be able to detect that it's coming in real time. And how do you do this, right? So you have now, assuming you have the expensive FPGA-based sensors, or you have the other method we talked about where you can have legacy sensors going through an aggregator card that NVIDIA has created, and you have all this traffic. How do you analyze it? So we created an extension for HiveMQ MQTT broker. Then we also created one for Mosquito. And we wrote this GPU-based broker that basically you put it on an on-prem box like this, and all the messages that come in, they're first processed on the GPU. Then we are able to forward the traffic to the local MQTT broker, which could be HiveMQ, could be Mosquito. But the problem we're solving there is we need to isolate the signal from the noise. And so if we're doing simple GPU thresholding, where we're saying, well, we're only interested in these sensor tags if they exceed a certain value. So that if you just do processing on the GPU, you can process 26 to 28 million messages per second. It's pretty fast. That narrows it down to a smaller subset of data. You provide JSON-based configuration that basically says, I care about this, I don't care about that. But still, at the end of the day, on that on-prem box, there is a set limitation of how many messages per second that MQTT broker can take. And maybe your funnel is such that you're not filtering everything out just to come right to that spec of HiveMQ. So we're going to be dropping messages. And what we had to configure was prioritization. So there are different level of priority assigned to different types of messages to say, if it's this kind of message and it's priority 1, if it comes, I want to forward it anyway. But if it's some less important message, drop it, right? And so at the end of the day, from 26 million messages, we're coming down to 8,000 messages per second that the local HiveMQ instance can process. And then it gives the manufacturer the ability to react to it however they want. You know, if they want to shut off the valve somewhere, they can do it. But that's up to them. But then going back to what's really valuable when you have this high frequency detection, it's with how much certainty you can say that this is not a false alarm, right? And so that's where the sliding window algorithms come in. And so at Prove It, we were running 3 such algorithms at the same time, where you have this digital sliding Fourier transform, and there is a window moving, and we're analyzing all the data points in that window. And so we were able to process 5 million messages per second on the GPU and know with statistical certainty that, yes, there is a problem. And then send the problem signals to HiveMQ to say, yeah, here's your indication. So it's all about the art of filtering out the noise. Now, to go back to what you said with historians and manufacturers collecting all sorts of data, our experience has been that LLMs work best if you pre-filter the data and give them what's relevant, a smaller subset of data points. So for example, if I have data out of a historian and I could pull out 200, 300 data points, depending on what kind of LLM I'm using in what mode, it might not give the best observations. But if I give it 15 or 20 data points, then it's easy for an LLM to see the trend, and it will happily categorize the trend for you. So then the question is, do you use a deterministic process to reduce the noise or to aggregate data and give the LLM something to work with at that point? Or do you use a non-deterministic process where you give a lot of data to the LLM and you hope that it gives you the correct response? And so it's an art of finding the right balance here for the specific use case. Again, here, the caveat is it always goes back to the type of problem you're trying to solve, but most of it is trying to filter out the noise, find the right signal. So again, if you go back to the example, I was talking to one manufacturer recently, and so they have a lot of data in the historian. They have their account in Snowflake. Do you put everything from your historian into the Snowflake? Do you put everything and put it very frequently into Snowflake? So those are all the questions that need to be asked, because when I spoke to Snowflake representatives, they told me, hey, if you don't want to break the bank, you don't send data to us very frequently. You categorize it, you make certain decisions. So that's what I'm talking about. You have to be smart about how to use your data, right? And how stale can you afford for it to be? So if I'm loading all of the data from yesterday and I can send it in one batch and I don't care that today's data is not there for my analysis, well, that's great. You know, that's not going to break the bank. But if I need to know in real time, what are you going to send data to Snowflake every millisecond? No, you're not going to do that. So that's where the other use case for the on-prem AI comes in, because you can send it to on-prem and it doesn't cost you anything. Again, do you need to? That's like the use cases that we see a lot of times, they actually don't require this, as long as you do the pre-filtering and data preparation and then leave the insight portion to the LLM, then you're good. But then this is, again, where I rely back on the experience of having years of software architecting and understanding how these things work, that it's the right combination of deterministic and non-deterministic work, as opposed to somebody who is just very fresh at this, sitting down and throwing everything at the LLM. It might solve the problem. It might not be as consistent or as efficient, and it might cost you a lot, but it might solve it. So there's that option.
Absolutely. No, I think this has been fantastic, Konstantin. Thank you so much for all of your thoughts and insight. We'll definitely have to have you back on for a part 2 in order to finish the 2/3 of the conversation I don't think we got to. We have a bunch of absolutely fantastic comments in the chat. And so just definitely to chat, thank you guys for being here and all of the questions and comments and thoughts that you guys have had. Konstantin, as we look to wrap up, we want to ask you all of the questions that we ask all of our guests. The first is, Vlad will attest to, is one of my favorite. So we want to go ask you to predict the future. And so what I guess I feel like we would be almost negligent if we didn't ask you to predict the future of what the future looks like with artificial intelligence in the next 2 to 3 years.
All right. So just a disclaimer, I'm probably the worst guy to predict the future. Plus, as I told Vlad before this interview, in my family, we have this firm belief that as people get smarter and more mature, they get more humble. So who am I to predict the future, right? But if I had to put out my opinions on the short-term future, AI is not going to replace humans. That's number one. Universal basic income is a myth. That's number two. AI will have incremental, not magical gains. I love to see these headlines in the news where they show you a picture of Dario Amodei and say, you don't know what's coming in 6 months. Everything is changing. Like, okay, great. That's headline pornography. Well, I can say the rise of local on-prem AI, just again from a practical standpoint, because it's catching up. It's never going to be at the same level of capabilities as frontier models in the cloud, but it doesn't need to be for the type of problems that can be solved. And manufacturers love certainty of either fixed cost or just certainty of costs in general. They don't like the variable costs at all with cloud LLMs. So that's the quick rundown on future prediction.
Okay, I mean, those are a lot of predictions. We will not get into that. That is probably an entire hour there in and of itself. But we do appreciate the predictions there, Konstantin. Next question we always like to ask people for some career advice. So if someone is early to mid-career and is looking perhaps to get into more of the AI, maybe understand some of the solutions that you were just talking about, what are the best pieces of advice that you can give them?
Yes. So whenever I think about this, I always think, okay, where do people really deliver value? It's at the intersection of disciplines. So if a person knows more than one thing, that's great, because it's much more rare to find people that know a combination of things than to find a person that knows one thing specifically. That's kind of how it is, right? So when you talk to people who are young and aspiring students or mid-career people looking at making changes, I would say, ask yourself, what do you know how to do best? And then ask the question, how can I leverage that and learn something else that multiplies the value? So look at the intersection of disciplines. And I would say, of course, when you think about just learning one thing, keep in mind the difference between having access to the tools and craftsmanship. What I mean here is anybody can buy access to a tool, but what can you do with that tool versus a person who has 20 years of experience in that field that gets access to the same tool? So I know how now it's an exciting time and everybody jumps in head first into building all this wonderful software. And probably 90% of these people don't ever think about how they're going to maintain it because they don't have that experience.
Yes.
So tools versus craftsmanship, it's an important thing. So that kind of brings you back to, what are you an expert in? What do you know well? So try to leverage that. Don't waste that knowledge, but then also add the new capabilities like doing something with AI, but make sure that you don't negate all that life's experience that you already had, because it's valuable. It's out there. I'm sure there is some kind of angle where you can show some tremendous value. So I would like people to be excited about what they already know, and then empower themselves with AI tools and do great things. So entrepreneurial mindset, if I may say, I strongly believe in it. So I teach my kids to be entrepreneurs and always learn. So every day you should learn something new. That part doesn't stop. As soon as you stop, you fall behind.
Appreciate
Absolutely.
that.
No, I think all of those are fantastic. Thank you for that. Next, a book or content recommendation. I see you've got a couple here. So, what is your best? What are your best shots, Konstantin?
So yeah, there is a few, and again, I was delineating between personal, technical. So for the people that don't believe why I say UBI is a myth, there is this wonderful author called George Orwell. So look up The Animal Farm in 1984, and those two books will explain why UBI is a myth. But on a personal level, I really appreciate Mo Gaudat's books. I've read several of them, and Solve for Happy was the most impactful for me. And if you don't know who Mo Gaudat is, he used to be a Google executive that was in charge of AI development, that is now doing the speeches. And he had personal trauma in his life when he lost his son. And so all this philosophy started coming out of that. And Solve for Happy basically tries to say, can we apply mathematical reasoning to personal happiness? And you'll be surprised. The way he explains things, it's so simple. You basically can program yourself to be happy. And
can we? Yes.
Remember that. I remind myself, oh yeah, like there's no reason to be upset about anything. You can be upbeat about everything you want to be, as long as you tell yourself that that's how you want to be. So I strongly recommend looking that up. And then again, on Industry 4.0, you know my sources, the mastermind community, 4.0 solutions. When we talk about AI, I have certain people I follow on YouTube, and Nate Jones is one of my favorites because there's a lot of hype in different sections. Even people who don't normally hype, all of a sudden create these thumbnails on YouTube that are kind of hypey. So I appreciate people who do not hype and just deliver straight up value and say, this is what's happening right now and the world is not ending, you know? So that's my answer to that.
I appreciate
Awesome.
that. And we'll have those resources in the links for those who are listening or viewing this after the episode.
Absolutely. Konstantin, next up, a new question for this year. Some sort of startup or innovation idea within industrial automation. We are removing all constraints of money, time, and physics here. If you could build anything, what would you build?
So since I can see that it is now possible, when we speak about continual learning, that relates to making sure that the LLM itself learns all the time. So we haven't reached that. But what we have reached is the capability of regular guys like me to use reinforcement learning through human feedback in our offices. So how does that work? That's the on-prem solution. And look into how do I make my agents learn instead of how do I program my agents? And again, we talked about having the fixed component. So there is always going to be this mix between deterministic and non-deterministic outcomes. If you want steady control, it has to be deterministic. But you can have parts of your code that are fixed and parts of your code that change depending on the learning. And I think this is where on-prem is really going to shine. Because why on-prem? I'm actually doing it not on-prem right now, and it's very expensive. So when it's hundreds of dollars each day, just because this learning system is burning tokens so fast, you want to move it somewhere where you're not paying for all the tokens. So that's the main premise why that would need to be on-prem too.
Okay. I like it. I think you touched on a really interesting point, is how expensive some of these AI solutions are. I mean, we've talked about $5,000 almost servers, and that is barely touching what the cost of some of these solutions could look like, or the cost of going and training some of these models. A lot of what I've read is in the billions of dollars if you're going to go do some of this model training, which is just absolutely wild. Last question for you, Konstantin, is how can our listeners help? Who should reach out? Who are you looking to connect to? Kind of your open platform to ask the listeners anything that you'd like.
Yeah, so thank you for asking this question. I would break it down into three categories, right? The frustrated plant manager or the end user that has a big mess on their hands and doesn't know how to make sense of it, how to get better efficiency. So again, we're bringing it back to not, hey, I would like to use AI, but I don't know how to use AI, but more like messy environment where you have a clear goal of what you would like to improve, but you don't know how. And that's where people like me, and there are many other people like this, and some of the names I recognize from the comments in our audience can absolutely help with this, is come into that messy situation and help start to make sense step after step, in that. And then you have the hardware infrastructure pioneers who are also eager to experiment with bringing compute on the edge. So I would love to connect with those people. I'm already doing that, but I would always like to learn other people's perspectives. And pragmatic software architects. As much as I hear that software development is dead, again, going to the comment about the experience gap, access to the tools versus craftsmanship. If you understand the math of burning tokens and you're figuring out a way to cap the cost but extract more value, I absolutely want to talk to you, because this is the name of the game. How do you extract the value without spending a fortune on it?
Absolutely. No, I think all of that is fantastic. Thank you so much for joining us, Konstantin. Thank you, and thank you everyone who has been watching along or is currently listening along live, especially for all of the folks in the chat. Very active chat the last couple of weeks as we've been talking about industrial AI. Vlad, that is probably telling us something, which we may or may not discuss at some point, or remember that it's telling us something. So again, if you guys are still watching and listening, thank you guys so much. Please make sure you connect with Konstantin. Make sure that you're following Manufacturing Hub and Vlad and myself. Again, thank you to MaintainX for sponsoring this theme. Nick will be on next week. Very excited to go do a deep dive into what MaintainX is doing. If Nick is watching live, Nick, this is a very deep, very technical episode to follow up on. We are excited to see with what you come with. If you guys are on YouTube or listening on podcast format or any of those, please do the like, follow, subscribe. Please rate us 5 stars. Please follow along when I remember to remind you guys, and Vlad publishes the episodes. More people listen to the podcast, and it's one of those linear things. And so we've been happy about it. But